Okay, I realize a lot of material is covered in this section. Some of it is horribly confusing, by the way. But what I'm doing is I'm looking at the absolute value of AN. All right, so what I'm going to do right over here is that I hope you realize that if I did that, that this would be greater. I'm going to write this over here. And the absolute value of that, well, that would be 1. This would be J, and 3 to the J. All right? And so if I look, that doesn't look like 3 to the J, though. Got to make that look a little cleaner, right? Okay, so I hope you realize that this guy here is greater than the other guy. And why is that? Well, it's an addition of terms where this thing has got, little takeaways from it, So I'm pretty convinced, if you gave it a little thought, that that's a reasonable thought. I'm going to erase that now. And what I'm going to do is move on to the absolute value of the term, see what happens there. And what I want to do is I want to get a comparison and something I know about. And I don't know about many things, but certainly looking at it, I'm going to say the absolute value now. So I'm going to be looking at the absolute value of this term over here, right, is going to be equal to 1. Maybe I should write that down. The absolute value of minus 1, J plus 1 over J, 3 to the J, is equal to 1 J. Remember, J is a positive number. It starts at 1, goes off to infinity, 3 to the J. All right, so what I want to do is get a comparison, something that's above. It's a positive term series now. So I'm looking for something that's above that. And what's above that? Well, let's take a look. I'm going to say a simple geometric term, right? I can use the same letters. I'll still use J. All right? So I hope you can convince yourself that that's true. Now, if you can't, let's go through that. If I simplify that, everything's a positive term, so what would you get? Let's write this down. You would get 3 to the J over J, 3 to the J, less than 1. I'm going to put this over here now. You know what? I don't have to do that. Let me just do this over here. I'll erase this again. And what do you get there? You get 1 over J is less than 1. And this is true if J is greater than 1. Right? I see this written over here now. So what do I know? It's a convergent geometric series. So if this is convergent, what's below it would be convergent. All right? So I got that covered. Let me erase this over here. Again, we're just looking at the key. We're at problem number 22 now. We're kind of just working through the key. So I'm going to outline what I just did over here. I get my highlighter out. And I took the absolute value of the nth term, and I got this over here. We just went through that, all right? It follows that our infinite series is convergent as it's related to the convergent geometric series. We're using a comparison test. All right, that's all we're doing, comparing this thing to a convergent geometric series. And it's convergent. It says a common ratio. Whoops, I noticed I made a spelling error. I've got to correct it. That should be ratio R, where, again, geometric series would be convergent where that common ratio, the absolute value is a proper fraction. All right, and then what I went through there, I did the ratio test over here. Not necessary, but I did a ratio test here. You don't have to do that, by the way. This is sufficient what we got written down for you. Thank you.